Hello, welcome to this video for Words with AQA. This is the skeleton code for the AQA Computer Science Paper 1 exam taking place in June 2018. We're going to look at the code in Pascal, although I hope you'll find this useful for any programming language, as the data structures, the classes, the algorithms will be the same. It's just the syntax that will be different. We'll start by looking at those classes and data structures. First of all, we've got the tile class. This stores the values for a single tile. The value is an integer which stores the worth of that tile, the number of points. The key stores the letter. You'll see it's got a constructor method there for creating a tile. All three of those things are public, meaning that they can be accessed anywhere in the code. Tile dictionary is another class, and you can see it's got a number of properties and methods, all of which are public. Firstly, we've got tiles. This is an array of tile objects referring to the tile class that we've just looked at. Tile count is used in the create method when we're basically adding new tiles to the tile dictionary, and we'll look at that in a bit more detail later. And this is the create method for creating the tile dictionary, and you see there's an add method as well, and find tile score, and we'll look at how they work in a bit more detail later on. Queue of tiles is a class that's used for storing the queue of characters that can be added to a player's hand after they've played a word, for instance. This is where it gets quite interesting. You'll notice that we've got these three attributes here, contents, rate and max size, which are set to protected. So rather than being private, which would mean they're only accessible to the class itself, or public, meaning they're accessible to anything, protected means that they would be accessible to objects in the class and also subclasses. So possibly a clue there as to one of the questions that might come up in the exam. Contents stores the queue of tiles itself, the letters. Interestingly, this is not an array of chars but an array of string. Again, interesting choice, maybe a clue as to a question that might come up in the exam. Max size stores the maximum size of the queue. This is used when the queue is created and when new tiles are being added to the queue. Rear is a pointer to the last position in the queue, and we'll look at how this is used in a bit more detail later on. Again, we've got a public constructor method to create the queue of tiles, and we've also got a few other methods here: is empty, remove, add and show, and we'll look at how they're used later on. We also have these two user-defined types, declaring an array of integer and an array of strings. Interestingly, t-integer array isn't actually used in the code. So we'll now start looking at the subroutines. Our code will begin executing. If you're looking at Pascal, this is right at the bottom of the code, and it calls this subroutine called main. So we'll now start looking at the code proper, and the first thing after displaying this welcome message is to call the subroutine load allowed words. So load allowed words is a function, and it returns this array of strings. Remember, this is our user-defined data type. It sets up a few local variables, one of which is list size, an integer which gets set to 0, then calls assign file. This means it's going to get the file handle for the file stored in the local user area called AQA words.txt. This is the data file provided by the exam board. Next, we've got a try finally. So this is our example of exception handling. It's going to try and open the file, and if it isn't successful in doing that, this is where the exception handling will come in if, for instance, the file doesn't exist or something like that. So reset is going to open the file to read, and then we've got a while loop. So while it's not the end of the file that it's opened, it increments list size, this integer which was set to 0, and then it calls set length, passing allowed words, the array string, and list size, the variable that we've just incremented. The purpose of set length is to resize an array, so in this case it's going to resize this allowed words array to the size of list size. So the first time round our loop it's going to set the size of the array to 1. Next it reads in a line from the file and stores this in this local variable called word. It then converts that to uppercase and then adds that into our array allowed words. List size -1 indicating that the array bounds start at 0 because we started off list size 0, incremented it to 1, and then we're using -1, so allowed words first element will be element 0. The word gets put in there. So the overall effect of this loop is to read in each word from the file, place it into the array, read in the next one, place it into the array, and so on. And once it's got to the end of the file, meaning it's read in every word from that file, it will close the file and then return value. Return value is what we've got here. The function is called load allowed words, meaning we're assigning that to be the return value. And this is the file that it's been reading in, so it reads a word, puts it in the array, reads the next word, puts it in the array, and so on until it's gone all the way through the several thousand entries in the file. So we now return back to the main procedure, and the next thing it's going to do is have this call here to create tile dictionary. So this function is going to return an object. Is going to be an instance of the tile dictionary class that we looked at the start of the program. The first thing it does is it calls tile dictionary.create. So this is the constructor, and the returned object will be in this variable tile dictionary. All the constructor does is set tile count to 0 and sets the length of the tiles array to 26. The code that follows adds the tiles to the tile dictionary, and it does this for every letter in the alphabet. And the way that it does it is quite interesting. We have a for loop that goes from 0 to 25, and this represents the letters A to Z, 0 being A, 25 being Z. And as it goes round this loop for 26 instances, it will look at the current value of count, and when it adds that letter to the dictionary, it gives it a weighting. This value you can see here is the score that's going to be available for playing that tile. This CHR 65 plus count, well, if we think of our ASCII table, 65 would be the character for A, so 65 plus 0 the first time round our loop would give us 65 for an A. The next time round it would be 65 plus 1, giving us the character B. 65 plus 2 the next time round would give us a C, and so on and so forth. The tiledictionary.add method simply adds a tile to the tiles array, which is part of the tile dictionary class, and that in turn will call the tile.create, which simply takes the two values, key input, which is the character itself, and value input, which is the weighting, the value of each tile. I'm not going to look at those in detail because they're relatively straightforward. And once the function has finished, it returns tile dictionary as its return value. So we've returned back to this point in the main procedure. The next thing that happens is these few local variables get set up. These are some of the parameters of playing the game. Notice these being hard-coded is not ideal, and it'd be fairly easy to change the game so that these are values that could be selected or entered by the user at the start of the game. So now that we've set up the list of allowed words and the tile dictionary, we start entering this loop here, and this is the main part of the program, I suppose, where it's going to display the menu and the user can start playing the game. So we can see it sets choice, this local variable, which is a string, it sets it to an empty string, and then while it does not equal 9, which is the option to quit, it goes into this loop. So the first thing it will do is call display menu. And there's not much to say about this one, it simply displays the menu on the screen. We've got three options: play the game with the random start in hand option 1, play with the training hand option 2, or 9, as I said before, to quit. So we return back to the main procedure again. The user is prompted to enter their choice 1, 2 or 9. This is read into the local variable, and play game is going to be called so long as they haven't entered 9. The only difference to how play game is called, you'll notice there's a number of parameters that are being passed here to play game, and the only difference is really whether or not they want to use the set of training tiles. So this is the play game subroutine. You can see a lot of parameters are being passed into this subroutine. It says procedure, so there's no return value. Local variables being set up here. Some of these are getting initialized, so the scores, the tiles played gets initialized. And then we've got this call here to the create method of queue of tiles. It's been passed this value 20, again something that's been hard coded, this value here, and this method will return a tile queue. So let's have a look at queue of tiles.create. So this is the constructor method, so it's going to create an instance of this queue of tiles class, so we're going to end up with an object. It's been passed this value, which is hard coded as 20, again something that would be very easy to change in the code. Set length is used again, so that contents is going to be set to this value max size, which has been coded as 20. Just a reminder that contents was one of these protected attributes in the queue of tiles class. It's set as an array of string, it's protected, so remember this means that if there were to be a subclass created, that would have access to this. Recall also that rear is another one of these protected attributes, which is an integer, and this points to the back of the queue as it were, so it's been initialized to -1. And then we've got this for loop which goes from 0 to max size -1. So remember it's been passed 20, so this is going to go from 0 to 19, and it basically sets the contents to nothing and then calls add. The purpose of the queue of tiles add method is to add a random letter from the alphabet to the queue. So the way it does this is, first of all, it will check if the queue is full. So if the rear of the queue is less than max size -1, then it will generate a random number. So this will generate in Pascal a random between 0 and 25, and then it will add 1 to the rear pointer, and then it will generate the character for that. So similar to what we were saying before, it gets the ASCII value. 65 would be A, so if it generated say a random value of 0, that would be 65 plus 0, converts it into the letter A and adds that to the contents array. And execution would then return to this point here, and at this point we're still going around this for loop until we've got up to max size -1, meaning that we'll have filled up our queue of tiles with random letters. So after creating the tile queue, the game will then see whether the player chose to use the training hand or to have a random start in hand, and this is indicated by this random start, a boolean variable that was given a value of true or false depending on which option was chosen from the main menu. So there's a chance at this point that get start in hand might be called. Get start in hand will return a string, which is the list of tiles that that player has in their hand. It gets this by looping from 1 to start hand size, which is this parameter that's been passed to it, and within the loop it will remove a tile from the queue and add that to the player's hand, and then it will add a new tile to the tile queue. It's worth at this point having a look at the queue of tiles remove method. This removes a single tile from the queue, but the way it does this is quite interesting. Firstly, it calls the isEmpty method, which checks whether or not the queue is empty, and I'm not going to look at the code in detail there, but all it does is check if the rear pointer is set to -1, in which case it would return true, in which case the item would be set to this empty string here. Otherwise, it implements a shuffle queue at this point. Firstly, it sets item to be equal to element 0 in the queue's contents, item will eventually be the return value from the function. And then we have this for loop that goes from 1 to rear, where rear is the rear pointer of this queue. So it's basically looping through every other element in the queue. And it sets the contents to count -1 to contents count. In effect, what this is doing is if it takes from element 0, it will then shuffle element 1 to 0, 2 to 1, 3 to 2, and so on until it reaches the end of the queue. And then finally it sets the final element to this empty string and sets the rear pointer to rear -1. So we'll resume execution here. We've either called getStartInHand for a random hand of tiles, or we've got the hard-coded training hands that you're more likely to be asked to use in the exam itself. So we enter this while loop, which checks a couple of things. It checks whether either player have fewer tiles played than the maximum number of tiles played, and this was one of the variables passed into this procedure. It will also check whether the number of tiles in either player's hand is less than the maximum hand size. If all of those things are the case, then we'll go into this block of code here, which starts with have turn, and you can see it's passing a number of parameters for player 1 into this subroutine. So let's look at have turn in more detail. So this is the have turn subroutine, which is called whenever one of the players has a turn of the game. Just quickly notice that some of these parameters that are being passed into the subroutine are being passed by reference. This is where we've got the VAR in front. This means that if the values are changed within the subroutine, then those values will also be changed from where the subroutine was called as well. Many of these values that are being passed in are dependent on which player's turn it is. So, player name, player tiles, and so on would be the values for player 1 or player 2. And then, of course, it needs access to things like the tile dictionary, the tile queue, and so on. A few local variables are being set up here, and then when the subroutine starts, it will output the name of the player, whether player 1 or player 2, and then there's a call to display tiles in hand, passing to it player tiles. This is display tiles in hand, and all it does is it outputs to the screen the string that contains the tiles that the player currently has. New tile choice and valid choice are initialized with some values. These are used later on, and these are to do with when the player takes their turn and whether they want to refill their hand and so on after they've made a choice, and we'll look at these in a bit more detail later. So we go into this while loop here while not valid choice. Valid choice is just being set to false, so it will go straight into this loop, and it calls this subroutine getChoice. GetChoice is a function. It's going to return a string value. The user is given some options as to what they would like to do, so they can either enter a word from the tiles in their hand, or they've got some other options here. This is read into this variable choice. It's converted to uppercase, and this becomes the return value. The code then goes into this selection statement where it looks at the value of choice, and if you didn't catch this from that last subroutine there, 1 means display the letter values, 4 is to view the tile queue, 7 was to view your tiles again, and 0 was to fill your hand and stop the game. So if they've chosen 1, it will call this subroutine display tile values, and it's passing to that tile dictionary in a loud word. This subroutine has a for loop, and it's going to use this counter to go from 0 to the length of the tile dictionary, the number of tiles in there, -1. Remember, this is an array of tiles within this class. It goes from 0 to the length -1 because it starts at 0. And it will output key being the actual tile itself, the character, and the value being the number of points that you can get for playing that tile. And it will go through the whole array, outputting the tile value and the tile character. If the user selected option 4, then they wanted to see the queue of tiles, so it calls the show method of the tile queue. And this method will firstly check if the rear does not equal -1, that means if the queue is not empty, and it will output the contents of the queue. So it's got a for loop here that's going from 0 as far as a rear pointer, and it will write the contents array, that's the contents of the queue of tiles. If the user chose option 7, then they wish to see the tiles that they currently have, so it will call display tiles in hand. And this subroutine is incredibly straightforward. It simply outputs the player tiles. This is the string that contains the tiles that they currently have. If the player chose option 0, this is to fill their hand and stop the game. So it will set valid choice to true. This will force it to drop out of this while loop here, and it calls fill hand with tiles, passing to it the tile queue, the player's hand that's got the tiles in it, and the maximum hand size. And this is a subroutine that I've already mentioned. So this will go through and it will say while the length of the player's tiles, that's the length of their hand, is less than the maximum hand size, it will remove a tile from the queue and add it to the player's tiles, and then add another one to the tile queue. And a reminder that this is the remove method, and this is where it's using this shuffle queue where it shifts all the contents down after removing a tile. Recall that when you fill your hand with new tiles, it removes one from the queue, so it then needs to add a new tile to the queue, and this is how it does that. So this is what was mentioned before, where it gets a random value and then adds that to the contents of the tile queue, again using this idea of taking the ASCII value and adding the random value to that to get your letters A, B, C and so on. So we now get to the point where the user hasn't chosen one of the numbers from the menu, which should mean that they've entered their choice of words, i.e. they've entered a word using some of the tiles from their hand, hopefully one that's in the dictionary. So the first thing it does is it sets valid choice to true, and this is quite a big subroutine, so let's start having a look at the next section of it. So now the code will start checking if the word that's been entered is actually a valid word. So the first thing it does is it will check if the length of the word is equal to 0. If it was, then it sets this valid word boolean to false. Next, if that's not the case, so they've entered at least one letter, it will call check word is in tiles. So this subroutine will receive a couple of parameters. So this is the word that the player has tried to play, and this is the tiles that they've got in their hand, and it will return a boolean. So if it's valid at this point, it will return true, otherwise false. Interestingly, the player tiles variable here is passed in by value, and then a copy of it is made into this variable called copy of tiles. It goes into there, and then all the processing is done on this. I'm not really sure why that would be the case, as player tiles is only passed in by value anyway, so its value can't be changed. So what this subroutine is going to do is it's going to iterate through the word that the player is attempting to play from 1 to the length of the word. It's going to look if the current letter in the word that they're trying to play is in their hand. This is their tiles that they've got in their hand. This function will return its position, so the position of the letter in the word they're trying to play in their hand. If this function returns a value of 0, then it means it's not there. It means they've tried to play a letter that they don't actually have in their hand. If it's given as a position of greater than 0, that will be the actual position in there, in which case it will call this delete function, which in effect will remove the letter from their hand. And this is then going to be repeated for the other letters in the word that they're attempting to play. Finally, we'll get this return value. So you see how in tiles is being set to false. If the letter in the word that it's currently checking isn't there, it gets set to false, and so that will be the return value if they've tried to play a word that contains a letter that they don't have. Otherwise, it will return true, it will remain true. So execution will return to this point, and hopefully the word that's being played is only made up of letters that they have in their hand, in which case valid word has returned true. So then the code will check if valid word is true, and if so, then it will perform the next check, which is check word is valid. So this is another function that's going to return a true or false value depending on whether or not the word remains valid. The word that's attempted to be played is stored in word. Allowed words, this is the array that contains the contents of the dictionary file, so all the words that are allowed that have been read from the file at the start of the program. Valid word gets initialized to false, and it will remain so until the word is found in the dictionary. And we use this counter, which is set to 0, and we have a while loop that will keep on going while count is less than the length of this allowed words array, meaning it's going to go from 0 to 1 less than the size of the array, and valid word equals false, meaning that it can stop this loop as soon as it finds out that the word is valid. This means that the subroutine has been made slightly more efficient because this loop can stop when the word is found rather than carry on reading all the way to the end of the array. Although you would think really that there's got to be a more efficient way of finding a word when they're stored in the array alphabetically, so it might be a good idea to revise, for instance, your binary search algorithms. Anyway, finally, valid word will contain true if the word was found in the array, otherwise it's false, and this then becomes a return value. So program execution will now continue from here. If the word was found in the dictionary, valid word is true, so we get this output here, valid word, and then we've got this call to update after allowed word. So now that we know that the word that's being played is valid, we've got a bit of updating to do. Firstly, player tiles played. This stores the number of tiles that the player has played so far, so we get the length of the word and add that. Next, we need to remove the tiles that have been played. So this line here for letter in word means we're going to go through each letter, which is a local variable, a char, in the word that's been played, which was passed to the procedure. So for each letter, we're going to delete that letter from the player tile string. This is a function that will delete a character or characters from a string. So it's saying from player tiles, we want to delete the letter that's at this position, and we're deleting one letter. The position we're getting by calling the pos function, which will return an integer, which is the position of letter in player tiles, which is the player's hand. Finally, the player's score needs updating. So to do that, we need to be able to call getScore for word, which needs to be passed the word that's being played, and it needs to be passed the tile dictionary as well. So let's have a look at that. So the first basis for deciding on the score for the word is to look at each letter in the word that's being played. So we use this for loop, goes from count is 1 to the length of the word, and it will look at the letter and use find tile score. The find tile score is a method of tile dictionary, and it will pass that letter to it. So find tile score receives this letter, a char. It will look for each tile in the tiles array. It will check if the current tile is the same char that's been passed into the subroutine. So if the key attribute is the same, has the same value as the key input that we've received here, and if it is, then it finds the associated value attribute, and this is assigned to score. Score then becomes the return value. So having called find tile score for every letter in the word that's being played and updating score every time, We then check if it's greater than 7 characters, and we get a bonus 20 points if the word is more than 7 characters in length. Otherwise, if it's more than 5 characters, then we add another 5, and finally the score becomes the return value. So we've made our call to get score for word, and the score then gets added to the player's score. So we return back to the have turn subroutine that we were in the middle of, and we've made our call to update after allowed word. So the next thing is this call to get new tile choice. So this is a subroutine that gives the user a choice of what to do after playing a word. So you can see that we've got this while loop here that looks at new tile choice, which is this char or local variable here, and it's saying while pos new tile choice 1 2 3 4 equals 0. That means that new tile choice, it's checking if it's got 1 2 3 or 4 in it, and if it returns 0 it means you've entered something other than 1 2 3 or 4. So it will keep them in this while loop until they give us a valid 1 2 3 or 4. If they've entered a 1, then they can replace the tiles that they've used, 2 to get 3 extra tiles, and so on and so forth. It reads that in, and then whatever their choice is, that becomes the return value. So we return again back to the have turn procedure. We've got their choice of what they want to do next, having played a valid word. At this point, there's another check here. If they haven't played a valid word, remember this was checking whether or not it was more than 0 characters in length, if it was in the dictionary, whether they're using their tiles and so on. If not, then it will say not a valid attempt, you lose your turn, and that's that. If new tile choice does not equal 4, option 4 meaning that they don't want to get any new tiles, then the next thing it will do is to call add end of turn tiles, passing to it the choice that they've just made, so that'll be a 1, 2 or a 3, along with the tile queue, their tiles, and the choice being the word that they've played. So the first thing this subroutine needs to do is to check what their choice was regarding new tiles. If they chose 1, it means replace the tiles that were used. So it takes the word that they've just played, this has been passed as a parameter, takes the length of that and says that's how many tiles need to be replaced. Otherwise, if they chose option 2, this means they want 3 extra tiles. Otherwise, they need to replace the tiles that they used and get another 3 extra tiles. So it takes the length of the word and adds 3 to it. We then go into this for loop, which is counting from 1 to number of end of turn tiles. This is the value, the number of tiles that they need, which we just calculated. So it goes from 1 to that, and it will remove a tile from the queue, add it to the player's hand, so it's basically concatenating that onto the end of the player tiles string, and then it adds another tile to the queue, and we've looked at this already. So finally, back to the have turn subroutine. We've called add end of turn tile, so we've possibly refilled the hand, and it's just left to output what is the word that was played, what their new score is, and the number of tiles that they've played so far in this game, and that now marks the end of the have turn subroutine. And execution now can resume in the play game subroutine. So we've just called have turn here for player 1. So the next thing after saying press enter to continue, have turn gets called again, this time passing all the player 2 variables to the subroutine. And remember that this loop of having player 1's turn, player 2's turn will continue now whilst the game is in progress. Remember we looked at this while loop earlier, and once the game is finished, then we have this call here to update score with penalty, and this is being called twice, once with the player 1 values, so that's player 1's score and their tiles and the tile dictionary, and then again with the player 2 equivalents. And the idea with this is it will work out the final scores. Let's have a look at this in more detail. So this subroutine will look at the tiles that are left in the player's hand. So this is the player tiles variable we've got here, which is a string, and it will go through every letter in that string. So if count is 1 to the length, it will look at that letter and it will find the tile score using the find tile score method, and the value of that tile is then subtracted from their score. So whatever is left in their hand at the end of the game, the value of those tiles is subtracted from their final score, and then this is the return value from the subroutine. And this is the find tile score subroutine that was called to get that. And what this will do is it will loop through every tile that's in the tile dictionary, and it will check if it's the one that was passed to it. This is key input, and it will check if that's the same character of the current one that it's looking at in the tile dictionary. It will get its value and then return that. So returning back to play game, the final thing after calling update score with penalty for both players is to call display winner. And this is the display winner procedure. It's fairly straightforward. It will output the scores of each player. If player 1's score is the highest, it outputs player 1 wins. Otherwise, if player 2 scored higher than player 1, player 2 wins. Otherwise, it's a draw. And that's it. So that then takes us to the end of the play game subroutine. So we're finally returned to our main subroutine, and we were in this loop here. So we've just called play game. It's the end of the game, so we'll go back around our loop and we'll keep going around that loop until the user has chosen option 9 from the menu, at which point the code will return to the main program block, which, if you recall, just had a call to main, and the program will stop executing. And that concludes this video. I hope you found it useful. Goodbye.